Good morning, grade 10. How are you today? Okay, so today we will start with the last chapter, which is chapter 14. Okay, it's about refraction. The first section, it's also called refraction. It's very important. It contains all the basics for this chapter. So stay with me. For sure, girls, you know the meaning of refraction. We already talked about it before. Okay, but so in this chapter, we will study it in much more details. Okay, so refraction, I will remind you about its meaning. So it's when the light bends. Why the light bends? The light bends when changes speed. Okay, so a fast revision about the speed of light. We know that the light is the fastest where all types of light, all types of electromagnetic waves from radio to gamma waves, they have the maximum speed in vacuum, which is a 3 times 10 to the power of 8 meters per second. Okay, we know that when these electromagnetic waves enter a medium such as the air, the particles in the air absorb this light and re-emit it again. So this process make our light slower a little. So the light in air is slower than in vacuum, but by a negligible amount. Okay, so it's like 2.999 something times 10 to the power of 8. Okay, so we don't take this difference into consideration. We just take the speed of light in air the same as the speed of light in vacuum, meaning that the speed of light in air is what 3 times 10 to the power of 8 meters per second. Okay, so now when the light enters a new medium, such as for example water, which is more dense, the particles in water are more packed together, so the light will be slower in water than in air. Okay, and even when the light passes through, for example, glass, the glass is solid, so the particles in solid are even closer, okay, are more packed together than in water, so the particles in solid, they will slow down the light more than in water. Okay, so for sure we have to know very well that this order, okay, in speed. So light is fastest in vacuum, then air, then water, then glass. Okay, so the slowest in glass, transparent solid. Okay, so light changes speed when it passes from one transparent medium to another, which causes the light to bend. Okay, so when the light enters now in another transparent medium, like such as water, so the light will bend. And this, girls, for sure you know it. We see it in our everyday life, such as for example pencil. When you put pencil or straw in water, okay, the straw appears to be broken, right? This because of refraction. We will talk about all of these phenomena later. Okay, so now we will talk about the steps how to draw the refraction of light. Pay attention with me. Here we have an example, air to water. Okay, this ray, the ray that's coming toward the surface, what do we call it? We call it incident or incoming ray. We know that. So always I taught you girls that after drawing the incident ray, we draw directly the normal. Okay, normal, which is the imaginary line, okay, the dashed line that we draw it perpendicular to the surface at the point of intersection. So after drawing the normal, we see or we show the angle of incidence, which is always measured from the normal to the incident ray. Okay, so now what do you think? Will this ray, this is the incident, will it continue straight in water, okay, as the previous path, like nothing happens? Okay, so for sure no, it will not continue straight, it will not continue in the same path, okay, as the previous one, because it enters now a new medium which is more dense than the first. Okay, so here the speed of light is what is slower, so this will cause the light to what, to bend. And see, how does it bend? It bends like toward the normal. This is our normal. it slows down, it bends toward the normal. Okay, so pay attention with me. This is the first figure, so we have to know how to draw these. Okay, so when the light travels from a medium which is in which the light is faster to a medium in which the light is slower, the light bends how toward the normal, toward the normal. Okay, because it slows down, it enters a medium which is more dense, so it slows down, so it bends toward toward the normal. Okay, so this angle now, what is this angle called? The angle which is measured from the normal to the refracted ray. So this ray, what do we call